The next sort that I want to talk about with you is one called radix sort. Sometimes this is called bucket sort, though actually technically bucket sort is something different, but it's very similar. In any case, this is something called a non-comparison sort, in that you'd never actually directly compare numbers to each other. Use a method called bucketing. And you can kind of see this happening here. It's really strange. So you can't even really measure it with big O in the sense of it's not going to be n squared or anything like that. It actually ends up being, I think, nk. But we'll get into that here in just a second. So yeah, it's a non-comparison sorting. We do something by actually asking comparing different number places instead of comparing numbers directly, and I'll get into that here in just a second. So we're going to sort parts of the array first, right? So let's take a look at this array that I have here in my notes: 109, 224, 901, and 58. So the first thing that you're going to do is you're actually going to sort it by the ones first. So 9, 4, 1, 8. So you can see here, after the first pass, we have 901, 224, 58, and 129, right? So you can see it's actually sorted by the ones place. Then we're going to sort it again, but by the tens place, right? So after the second round, we have 901, 109, 224, and 58. Then we're going to sort it one more time by the hundreds. So at this point, we'll have 058, right? Because there's a 0 here. 109, 224, and 901. And you can see after having done that, sorting it by the hundreds place, which is the largest, place that there is, we end up having a sorted array. Kind of a mind-bending way of sorting. It's not something that a human would ever kind of think of directly. So you can kind of see that happening here. That it'll sort them into buckets by zeros, ones, twos, threes, and fours, and you do it for however many places there are. So in this particular case, there's up to 1,000, so we do that sort 4 different times. Make sense? Sort of? So, again, what's the big O of this? The big O of this is going to be a little bit different than we're used to, because we have to account for this, how many buckets or how many times we have to do the sorting, right? So we're going to call that term K or W. In this case, let's just go with K. And instead of being O n squared, you end up being, which is n times n, you end up being n times k. So it's kind of like n squared in the sense that it's two different terms multiplied to each other. So you might ask me, is this better than n log n? Well, as you may have guessed, being this far in the course, it depends, right? It depends on what the distribution of your numbers are, right? So if you have a lot of very long numbers that are distributed really well, right? So there's like kind of a uniform distribution over with lots of terms, right? So if you have hundreds of thousands that are distributed across that entire range, then radix sort actually ends up being a pretty good sort. But if you're sorting, 500 numbers and they're all between 0 and 100, it tends to be kind of inefficient, and you'd be better off with something like quicksort or something like that. So spatial complexity ends up being n plus k, where n is the length and k is how many places there are to sort by. So it's not great on spatial complexity because you have to do a lot of bucketing. So that's why it's only favored in pretty specific circumstances. But I wanted to show you how you can sort things without actually directly comparing numbers, right? So like in this case, 109 is actually never directly compared to like 901, right? The only thing that they're ever compared by is just by these buckets. So I'm going to give you a chance to try and code this up. I'm going to help you kind of get started here. That's fine. We're going to be, and actually I'll just come back to here. That was quick sort. Let's get into radix sort. Okay, so you can see here, these are all the numbers that you're going to be sorting by. And if you want to just do something for fun here, you can actually do this. It'll just sort 99 very long numbers for you. So you can see how efficient this actually can be. But this is kind of extra credit down here. Let's focus on this one up here. Okay, so we're going to do a radix sort here. So I'm going to just advise you on some helper functions I think you should code for yourself. One should be function get digit, where you give it a number, a place, and the longest number. So for example, if I put into, like, let's say I have a number like 1391, so that would be the number, and I give it a place of 0 because I want the 0th place, and I have the longest number in here. Is that correct? Am I doing? Got to make sure I'm doing this the right way. And then the longest number in here. So the longest number would be like the longest number in your particular set, right? So if I had a number like 30,000 in my set, or let's even look at this. The longest number in this set is of length 4, right? So 3,000, 1244. So the longest number in that particular case would be 4. Actually, let's say there. And 4. In this get digit, that should return here the 1, right? Number equals that, place equals that, and longest number equals 4. Sorry, I'm just making sure that I get this correct. Anyway, this get digit helper here is going to help you here, so that you can just provide these numbers here so that it helps you with the bucket sorting. Then I would also just write a function called get longest number. A lot of times you'll know this going into your data set, right? You'll know that the longest number will be of length 4, length 5, or length 6, or something like that. But in this particular case, I would just provide that here, get longest number. And in this particular case, get longest number, if you call it on this data set, would return 4, right? Right, the reason why you need longest number here, that's what I was trying to remember, is let's say the longest number in your data set is 3,000, but you give it number 3, right? So the longest number here is going to be, or sorry, not the longest number, but the place will be 4 on that, so you'll actually get back 0, if that makes sense. Okay, and then let's go into what radix sorting is going to do. So find longest number, create how many buckets you need. In our case, since we're doing base 10 math, this will be an array of arrays. Right, and then you'll have a bucket for 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, then here you'll have a for loop for how many iterations you need to do. So that will be based on the longest number, right? Because you need to do one iteration for each of the longest numbers. And then basically what you're doing is you're going to throw them in the buckets, and then you're going to dequeue them back out into your final results, and you'll keep doing that back and forth until you end up with the correct answer. So inside that for loop, you'll have a you'll enqueue, which is the word for just like throwing something into an array, the numbers into their buckets. This will probably be a while loop, that's why I have that. And then here, you're going to have another for loop for each bucket where you dequeue all of the results. That's more or less kind of step-by-step what you're going to be doing. I kind of diagrammed this one out because it's kind of an abstract one to think about. But the idea, again, let's just go back to our visual here to kind of, let's just take this step-by-step. So notice for each one of these, it's enqueuing them. Can I just make that bigger? There we go. First by the zeros, right? Zeros, ones, twos, threes, sevens, right? You can see the highlighted in red of the one that it's enqueuing at the moment. Then what it does, notice it just dequeues them out in order, right? So all the zeros are coming out, all the ones are coming out. And so after the first iteration, we have this array that's sorted by the ones places, right? And then it does it again. Notice that the red ones are now the tens, right? So now we're sorting by the tens place. And it goes back into these buckets. Notice that nothing's ever being compared to each other. We're never asking, is this bigger than this? We're just putting it into the buckets and then back out into the general result array. Okay, so this gets put back into these buckets by the tens place. Notice that 1 and 7 are in the 0, right? Because they have no tens place. And then these just get dequeued out again. And now notice that it's sorted by the tens and the ones place, right? So 1, 7, 10, 20, 21, 22, 27, 30, 38, 43, 77, 80, 82, 93, 99. And then we do it again for the hundreds. And then notice that it's sorted now by the hundreds. Right, notice that 793 is the last one in here now, whereas 1 is still the first one. And then you do it one more time for the thousands place. And then you dequeue all that back. And there you go. Now everything is sorted without ever asking, is this bigger than this? There's no if statement in there. It's just putting things in and out of buckets.